Welcome to the VS Code talk. So in this talk, I'm going to show a practical example of how you might use Visual Studio Code for your Julia environment. I will cover things like the new workspace view, the debugger, and then some of the remote options that VS Code provides. I think the announcement also said that I would showcase Julia notebooks. That will not happen. There was a small demo in the keynote, or was not a keynote, but in the other Julia talk, but it's not finished yet, so I'm not going to present that today. Everything I'm showing you today is actually stuff that ships and that you can try yourself. Throughout the talk, I will wear different hats, and I will sort of emulate a collaboration effort between different people. And we'll start assuming that I'm a researcher and that I'm writing some data analysis code. And then I will show you how you might use Visual Studio Code for that. And then we'll go into some collaboration scenarios for that. So here I have an empty Visual Studio Code window. I've opened a folder called VS Code Demo. It's completely empty. I want to start from scratch. And so the first thing for an exercise like that is that I want to create a Julia environment for that folder so that I exactly control which packages I'm using. So I'm going to open a REPL here, Julia REPL, that will show the REPL down here. I will activate the current folder in the package manager. And now I can add a couple of packages to this environment here. I'm going to use data frames, query, Vega data sets, and Vega Lite. So now I've created this environment here. The next thing I want to do is I want to click down here in the status bar and select that Julia environment as the active environment for this window here. So that means that all the code completion, inline help, and so on that we have in the editor will work off this particular set of packages. Okay, so next I'm going to create an empty file. We're going to call it main.jl. And inside here, we're going to write some code. So let's first of all load all the packages using Vega Lite, data frames, query, and see how we get completion here, Vega data sets. So I'm going to use the interactivity in this in our extension here to run code as I write it inside this file. So if I if I press Alt-Enter, then this particular line of code is actually being executed in my currently active Julia REPL down here. So while we wait that this finishes, I can actually continue to write some code. Let's say we're going to load some data, the cars data set, and we're going to assign it to the global variable cars. And let me just actually here in the REPL go out of the package mode here. So we ran this line of code here. So next, let's run this line of code here. So we press Alt-Enter again, and that will send that particular line of code or that code block down to the REPL and execute it in the REPL. So the first thing you can see here is that we now have inline showing of evaluation results. So here to the right of the expression that we just ran, we now see a short representation of the return value of that. And if I hover over it, then I actually get to see a richer rendering of this data set here. You can also use the new Julia workspace view here to explore the global variables that are currently loaded in your Julia REPL. So I click on this button here, and that shows me now the content of the global namespace here in the Julia REPL. So we have this global variable cars here. So that's the one I just created by running this line here. It tells me that it's a Vega data set, it's a type. And if I hover over it, it also shows me this little button here, which indicates that there's a richer preview available for showing that this particular data set. So if I click this, then we'll actually open a nice tabular view of that particular data set here that we've loaded previously. I'm going to close that again, and let's write some more code. Let's say we're going to take this tabular data set cars. We're going to use some query here. We're going to select a few columns, namely the acceleration column and the name column. And then I'm going to collect it. So that should store the output of this line here as an array of named tuples. So I'm going to run this. And again, it shows me the output here. And in my Julia workspace view now, I can look at the content of this particular last evaluation by looking at the ANS global variable, which always holds the value of the last executed statement. And so we see here that it is an array of named tuples. And for arrays of named tuples, I can drill down into the details of that by clicking on this little button here. And so now I see all the elements in this array. They are grouped by, they're put into groups of 20 elements. So let's say I want to look at the element 100. So I open this, node here, and then element 100 would be down here. So each element in this vector is actually a named tuple. So that's a structure with fields. And I can explore that by drilling down further. So here I see that this element has two fields, one field called acceleration, and the value is 13, and another field that's called name, and the value is Ford here. So this workspace view allows you to explore arrays, dictionaries, and composite structures, and easily look at the values that are stored there. Okay, so let's do a little bit more. Let's write a function here, function foo. It takes two arguments, data and origin. We're going to run another query here, and we're going to assign the result to the variable df. We're going to run this query on the data that is passed into this function here. And in particular, we're going to filter it by the value that was passed in as the second argument to this function here. So we're trying to filter all the rows out where the origin field is not what we want. And then we materialize this into a data frame. And then let's return a plot actually from this function. So I'm going to say return, taking the data frame that I have here, and I'm going to pipe it into a plot command. Let's just plot a scatter plot acceleration against miles per gallon. All right. So I want to execute this function. I can just have my cursor anywhere in here and press Alt-Enter. That will run that function definition inside our REPL, and so now we can use it. So now the next line, I'm going to call this function. I'm going to say call foo with our cars data set, and then I'm going to pass a string called USA. So we're going to only show the scatter plot for cars where the origin is USA. And the return value here I'm going to assign to the variable p. The return value will actually be a plot. So let's run this. And in this case, because the return value is a plot, it will immediately open the integrated plotting pane in VS Code and show us the plot here. So over here in our workspace view, we should now have a new global variable called p, which is a Vega Lite spec, which is the plot. And if I closed the plotting pane, for example, then for this plot here, I can again click on this Open in VS Code button to open it in a new plotting pane here. So that should work with any plot that you have. If you've assigned it to a global variable, you can easily open it up with a rich viewer from the Julia workspace view here again. Okay, so let's do one final thing. Let's save this plot as foo.png as a PNG file here, so that it ends up on disk. Okay. So let's say this was the whole data analysis that I managed to run here. And what I want to do now is I want to make this code available for others to replicate and run and try out. So how would I do that? Let me close that file here, and we can actually also close the REPL here. So the first thing is that I want to turn this folder into a Git repository. That's very simple here. The extension has a command called git initialize repository. I just run that and it automatically turns this folder into a Git managed folder. So now I can use the source code view here. It shows me all the pending changes. I'm going to say add initial version as the commit message here. And so now that's stored, that change is stored in the Git history here. Of course, that's not enough. I actually want to publish it onto GitHub. That's also very simple from within Visual Studio Code. I just say publish to GitHub. It asks me what name I want to use for this repository. So I'm going to call it VS Code Demo, and it's going to be stored in my personal account on GitHub. All right. I want to have everything included, and then I'm going to publish this. And it goes out there and uploads and pushes the repository to GitHub. And it's successfully published. So I'm going to do one final, one small thing here off screen. And that is I'm going to change the visibility of this repository to make it public so that we can use it in the next step. All right, so that happened off screen. But what's published now is a GitHub repository with this replication code. But because I'm a good citizen, I want to make it actually easier for other users to run this replication code. And so I'm going to add what's called a def container to this repository. And the way to do this is that you need to add a folder here that's called .def container. And inside that folder, you want to add a file called defcontainer.json. And this is a standard JSON file. And what I'm going to store here is information for other users, what kind of programming environment you need to successfully edit and work with this file here. And so I'm only going to add two very small informations. I'm going to say the Docker image that you ideally want to use for this here is the Julia image. So that will give users automatically an environment where Julia is pre-installed. And then I'm going to say the extensions that you want to use when you edit this repository here is the julialang.language Julia extension. So that's the Julia extension for VS Code. So all I've done here is I've added one file with this information. The runtime environment that you might want to have is Julia, and the extension that you might want to have is the Julia extension. So let's commit that also to Git. Add def container. Let's commit that and let's push this up into the cloud. So now we're going to pretend that I'm someone else, someone who wants to try out this code that the previous me uploaded to GitHub for everyone to try. We're going to make this a little bit interesting. We're going to assume that this new user, the new me, doesn't have a setup with Visual Studio Code installed or Julia installed or anything installed. This is a user who only has a web browser and wants to try out things from a web browser. So in this case, this user can go to Visual Studio Codespace, which is a web-hosted, cloud-hosted development environment. And I'm going to say, create a new Codespace here. I'm going to give it a name, JuliaCon. I'm going to load the VS Code demo repository into it. And then I'm going to say, create this new Codespace. So what's happening now is that in the cloud, a new virtual machine with a Docker image is initialized. Because the previous me specified that the Julia Docker image would be really useful, that's going to be used. So Julia will already be installed in that new image. And then the UI of Visual Studio Code will run inside a web browser, and that web browser will be connected over the internet with this virtual machine in the cloud so that Julia itself is running in the cloud, but the whole UI is running in your web browser. And you don't have to install anything. And if everything goes well, then we should have a fully functioning environment up and running in almost no time here. So I think this is almost done. And here we are. So here you see Visual Studio Code running in a web browser connected to a cloud machine that has Julia installed, that already has the repository cloned, all the files here, and we can go right away and try things out. So the first thing I'm going to do is I'm going to open a shell here. This shell is running in the cloud machine. I can start Julia in here, and I can, for example, activate the current folder here and instantiate it so that it installs all the packages that we want to use here. I'm going to pause briefly until this has finished. So I instantiated all the packages in this environment. And now let's assume that this user wants to run some code. So they open the main file here. They look at this and they say, okay, let's first of all run this code here in our REPL. So I select it, press Alt-Enter. That will send that code into a Julia REPL. This Julia instance is running in the cloud machine, but the UI for it is occurring here in our browser. So this will take a moment to execute. And then this user, the plan here is to run the foo function in the debugger to figure out what's actually going on here. We're going to set a breakpoint on this first line here of this function that we want to actually debug, so that when we run it, we break into the debugger at that point. And now I'm going to, from the REPL, say run foo cars USA. So I'm going to run the foo function with these arguments here. The run macro drops us into the debugger, and everything you write after it is run under the debugger here. As soon as the debugger reaches line 8, where we've set the breakpoint, we break into the debugger. We can see here in the debugger that the local variable origin, the argument, has the value USA, for example. And now we're going to add another twist to this. Let's say the user here is now confused and doesn't know what this code actually does, and they want to get some help. So I also installed an extension called LiveShare. And LiveShare allows this user to ask the original author of this GitHub repository to join this current session of VS Code to help out. So I'm going to click on LiveShare. It's starting what's called a collaboration session. It copied a link with invitation information to that session to the clipboard. Just going to copy that again. And now I'm going to change the screen here. We're going to assume that this window here in the lower right is a user that was invited to one of these LiveShare sessions. The user can click on LiveShare here, that's the extension. They can say join a collaboration session, paste in the link that they got from the user that started this collaboration session, and then connect to this. So what's happening now is that the user who's running the full version of Visual Studio Code is connected to the version that is running in the web browser, and both users are looking at the same live debug session that is up and running now here. I didn't want to close that. Okay, so let's say this second user who originally wrote the code looks at this, marks something here. You can see how even selections are shown in synchronized between these two instances here, and tells the first user, you know what, I think there's a bug in the code. You actually want to run the foo function not with the USA argument, you actually want to filter for Europe. So the user here in the web browser who's controlling the debug session can actually now change the value of this local variable inside the debug session. So here I have my local variables. I select the value here, I double click, and I can assign it a new value just locally during that session. So I'm going to say Europe. So I've changed the value of the origin local variable to Europe without restarting everything. I can do that within a running debug session. And now I can step over this line here to the next line, and it will use the value Europe here that I temporarily changed. And so now data frames here should be data here that only has rows that have Europe as the origin string here. And you can see even Hoover help for local variables works within this debugger here. Okay, so I'm going to finish this debug session. So I'm just going to run the rest of this debug session to the end here, and all should be good. Of course, other features like the workspace here work as well. So we see our local variables here, all the things that you're used to from the version of VS Code that runs locally on your machine. They also work equally well inside the web browser here. Things like Hoover help all work, right? So there's really no difference between the locally installed version of Visual Studio Code and this online version. All right, so I think I'm going to stop this collaboration session between our two instances of Visual Studio Code here. So I'm going to say stop collaboration. And just to recap what actually happened here, let me show you a few slides because there were sort of a lot of machines involved in this hypothetical scenario. So in this last scenario, we had one user, let's say user 1, working on a laptop. That user worked with Visual Studio Code in a web browser. That web browser instance was connected to a Julia workspace in the cloud. So Julia itself ran in the cloud. And the user was able to start a debug session in the web browser for the Julia process that was running in the cloud. And then at some point, this first user invited another user to help him out in a current session. This other user worked on a workstation. The other user actually had the full Visual Studio Code installed, so that was not a web browser version. And then these two sessions connected to each other, and both users were able to collaboratively work in one session, look at the same code files, and so on. So this is a really rich environment for workflows where more than one machine are involved. This really only scratches the surface of the remoting capabilities that Visual Studio Code provides. There are many other topologies for working with different machines that are supported out of the box and that all should work with the Julia VS Code extension as well. So I'm just going to list some of them here. So in general, if you have a VS Code client running, you can connect that instance with a workspace in different places. So we saw the example that it connected with a workspace running in Visual Studio Code spaces in the cloud. But you can also connect it to a local Docker image. You can connect it to a remote SSH machine. So you can have some SSH machines running somewhere. You can connect your local VS Code instance to that SSH machine and then run and debug things on your remote machine via SSH on your local VS Code. For Windows users, there's really good support of connecting to WSL instances. So that's another great option for Windows users to have the UI run on Windows, but the underlying Julia code actually run on a Linux machine. And you can also set up your office computer and then connect from any of your laptops to your office computer so that the UI is running on your laptop, but the actual code and Julia processes are all running on your office computer. So I, for example, have not been allowed into my office for a couple of months now. And so this is a great way for me from home to connect to my very beefy office machine and get a really snappy UI, because the UI is running locally on my laptop here at home, but all the computation is actually happening on the machine in my office. And that works via this Visual Studio Code Spaces technology, and it works through a lot of firewalls. So I can tell you, between my home computer and my office computer, there are multiple firewalls involved that are completely beyond my control, and it just works beautifully through all of that. So that really concludes what I wanted to show you here. I hope this was somewhat useful to give you an impression about some of the capabilities that you get from using Visual Studio Code in combination with the Julia extension to work on your Julia projects. Thanks a lot.